This coming quarter, I'm going to be teaching the Materials Science and Engineering course. In the past, I've done a variety of things. Electronics, I've done robotics, I've done fuel cell research, and various kinds of materials research, and ferroelectrics, piezoelectrics, that sort of thing. I have no idea what my future interests are going to be, but right now I'm part of a big research team. You may have heard of it. It's the CREST program. A lot of students are involved in it. It's an interdisciplinary research with the chemistry department, the physics department, NASA, and also University of Nebraska. And that is, generally speaking, on materials. What we're looking for are materials that are organic ferroelectric materials, and I would encourage all students to think about getting involved. Even if you're just starting out at the freshman level, don't underestimate yourself. Definitely get involved, and the time to do that is now. The applications usually come out in early calendar year, January or so. So take a look at our website, materials.csusb.edu, or feel free to contact me.
I am Dr. Sarah Clory. I am a second year professor here in the physics department at Cal State San Bernardino. Right now I'm currently teaching Physics 223, which is Waves and Optics, my favorite of the 220 courses. In the future I will also teach 221, 222, sometimes a lab in there, and if you sign up for Introduction to Electronics, you're going to get me, hopefully not at 8 in the morning this quarter. What research have I done in the past? My background is in thin film research, so by thin I mean take a hair divided by 10,000. We're talking about, tens to maybe 100 layers of atoms thick. So I'm interested in systems like that where I'm looking at properties like magnetism or something called ferroelectricity. It's kind of like magnetism, but with a little electric dipole, which you guys will learn about soon enough. So I work on films with those type of material properties, and that's something that we might be able to use for future or new electronics or computing devices. What are my current or future interests? I love anything that's thin films. I'm currently applying for grants to get a big fancy machine to make them here at Cal State, so hopefully that will be in the future. And I'm currently finding ways to work with Dr. Usher and the CREST group to bring my knowledge of thin films together with their knowledge of organic ferroelectrics. What else am I working on? I'm now collecting all the random toys in my offices and bribing students with candy to pick up their tests from last quarter. If you're in my class from last quarter, there's candy. Please come get your tests.
Hi, I'm Dr. Hood. I'm one of our full-time faculty here. And this quarter I'm teaching our Cosmos capstone, so it's an astrobiology course about life in the universe. I'm also doing our introductory astronomy course and one of the 223 labs, so that's dealing with waves and optics. Next quarter, I will jump into the sophomore level and junior level classes, so our special relativity class and our classical mechanics. And then I will continue that sequence for both of those in the spring, where we move into modern physics for the sophomores and continuing with mechanics for those students who are doing the traditional track for the physics Bachelor of Science. My research deals with black holes. I'm interested in the structure around the black holes, how the black holes grow, both on their own and also with galaxies. And a lot of that has to deal with determining the mass of the black hole. So that's some of what I'm doing most recently. I'm also involved in physics education research to a minor sort of degree, so I will be bugging my classes a lot with that sort of thing. And during the summer, I actually am involved in a lot of elementary school teacher workshops. So the state of California is updating their science standards, so it won't affect you, but it may affect your siblings or future children. And so I do a lot of kind of update their knowledge sort of stuff on physics and astronomy for those, because different grades are going to start doing different things in the next year or so. So that's a big part of my summer the past few years as well.
My name is Dr. Karen Colomited. I'm a faculty member in the physics department. This quarter I am teaching Physics 421, which is the first quarter of Upper Division Quantum Mechanics. In the winter quarter I'll be doing 422, which is the continuation of that course. In the past I've done research on areas related to properties of matter at very high densities and temperatures, a higher density and temperature than you'd normally find within the nucleus of an atom. That has applications to astrophysics in connection with the early universe shortly after the Big Bang, when the whole universe was that hot and dense. Also to the structure of neutron stars. It also has applications to heavy ion collisions, where we smash together two large nuclei in an accelerator, compressing them and heating them in the process. I've also done, all of this is theoretical research. I'm a theorist, not an experimentalist. I've also done numerical modeling, computer modeling of some biological systems, particularly a certain class of human genetic diseases that happens to be present in my own family. That's why I got interested in it. I haven't done much research, honestly, in the last couple of years, and probably won't in the near future, because I'm serving as chair of the Faculty Senate on campus this quarter, and as you can imagine, that's a pretty time-consuming job. It involves sitting on a lot of committees and so forth. So I haven't had too much time for research. But in the future, when I'm able to have a little bit more time for it, I'd like to extend some of the work that I did on the biological modeling to include some other genetic diseases as well. Thanks.